Hello everyone. So today we will discuss about the greedy method as part of the data structure algorithms. So this is part of the algorithms. In the algorithms, okay, we will discuss about the searching, sorting, and divide conquer algorithms, greedy method, dynamic programming, two pointers algorithm. These all comes under the algorithms. So if you haven't watched my previous videos, please check out those watch videos. And today I will focus only on the greedy method. So it's completely basic of the greedy. We will not discuss any question today. It's about the theory part, you can say. Means you will understand that for which problem we need to use greedy method and when to use, what are the advantage, what are the and what are the disadvantage of the greedy method. Everything will be covered. Now, so before going to the definition of the greedy algorithm, I want you to understand few terms like what is optimization problem, what is the minimization, maximization problem, and what is feasible solution, what is optimal solution. So first of all, we will understand these four problems and the four terms you can say. Once we are clear on these four, I will explain you the definition of the greedy algorithm. All right. So let me explain you these form terms with the help of one example. Now, let's say there is one question is you want to travel from point A to point B. All right. What it means is that let's say there is point in a city A, and from there you want to go to the point B in the city. So how you can go? You can go by car, you can go by bus, you can go by a bike. There can be multiple possible solutions are there. So in this case, let's say we have n number of possible solution just to go from point A to point B. All right. Now, this is just a normal problem, right? Now I will apply some constraint in this problem. Constraint is like that, hey, you want to travel from point A to point B, but I want the solutions which will take less than equals to 10 hours. All right. So out of these n number of solutions, each solution will take different time. Let's say one will take 10 hours, one will take 12 hours, one will take 15 hours, one will take 4 hours. So we will just pick the solutions which will take less than 10 hours. All right. So here let's say S4 and S5 are those two solutions which will give us the feasible solution. Okay. Now here you understood about the feasible solution is out of total possible solutions, the solutions which are satisfying the constraints are known as the feasible solutions. All right. Now let me increment this problem okay, a little bit more. What I am saying is, hey, I was talking about the constraint already, but I want the solution which will take the minimum cost. Now, okay, we have constraint, and after constraint, we got two solutions, S4 and S5, which are our feasible solutions. Now, out of these two solutions, I want the solution which will take minimum cost. So here, because both solution cannot take the same cost, okay, it can be possible, but let us think about that both the solutions cost will be different. So here out of these two feasible solutions, there is one solution which will take minimum cost, and that solution is known as the optimal solution. All right. That is the very important part here. You need to understand about that. So we understood about the total possible solutions. We also understood about the feasible solutions. We also understood about the optimal solutions. All right. Now here, what I was talking about is in this problem, we are trying to find out the minimum cost solution, right? So such kind of problem are also known as the minimization problem. Okay, so the problem in which you want to find the solution, you want to find the optimal solution with this minimum logic. Okay, that problem you can say as the minimization problem. Now let's say I will say about the some problem in which you want to get the maximum profit. Those kind of problems are known as the maximization problem. Let me give you an example. Okay, so here this is one of the most famous problem. This is also known as the knapsack problem, 0-1 knapsack problem, and the fraction knapsack problem. In that problem, what we have? Okay, let me explain you in the simple terms. Let's say you are a thief. Okay, you went to someone's house and you see there are a lot of things are there. You will see, right? Some money is there, gold is also there, silver is also there, right? So lot of things are there. Now you want to get the things. Okay, you have one bag with you, and in the bag there is some for the bag you can put some maximum weight, right? Because after that you cannot put some weight into the bag because the bag is already full. So bag has one term called capacity of the bag. So in this example, let me explain you. Your bag capacity is 30 kg. Okay. Here we have different objects. Each object has the weight and the profit associated with that particular object. So for example, here object 1 is of size 10 kg and whose profit, if you will get this object, you can sell it in 20 rupees, let's say. Okay, so similarly object 2 whose weight is 4 kg, and if you will sell it you will get 9 rupees. Okay, and so on. So this is the thing. Now what you want to get the objects into the bag which will give you the maximum profit, right? So this problem here we are calculating the maximum profit. So you need to find a solution such that how you will choose the weight, how you will choose the object which will give you the maximum profit. All right. So this problem is known as the maximization problem, and the previous problem in which we were just looking for the minimum cost solution, that is known as the minimization problem. All right. Now I hope we are clear about these four terms. What is optimization problem? A problem in which we need to find maximization. A problem in which you want to find optimal solution. It can be, right, the minimization problem, or it can be the maximization problem. That problem is known as the optimization problem, right? Now, what is the feasible solution? What is the optimal solution? Out of all possible solutions, the solutions which are satisfying constraint are known as feasible solution. And out of feasible solution, the solution which will give you the, which will satisfy your criteria of the minimization or the maximization is known as the optimal solution. Understood? Now I will explain you the what is greedy algorithm. All right. So to solve the optimization problem, we can use different algorithms. We can use the greedy method. We can use the dynamic programming. We can use the branch and bound. Also, we can use the backtracking. All right. So now you need to decide, hey, for which problem, which algorithm we need to use. Okay, don't worry about that. I will explain you. So we will understand about the greedy now. All right. So what is a greedy method? A greedy algorithm always makes the choice that seems to be best at the moment. All right. What it means is that it makes a locally optimal choice in the hope that this choice will lead to a globally optimal solution. Okay. Not clear? Don't worry about that. I will explain you with a simple example. Okay. Let's say you are standing at the point number A. Okay. From point number A, you want to go to the point number B. Okay. What you are saying from point number A is, hey, there are three different paths I can see. Out of three different paths, I can choose the one best path based on some criteria, let's say. Okay. And you will move forward. You will go to some midpoint, let's say point number C. From C point, again, you will apply the same logic. Out of all possible choice, you will just choose the one choice and you will move forward. So, right, this is the greedy only, right? So this approach is known as the greedy, means out of the all possible choice, choose the choice which seems to be best at the moment. All right. And we will hope that, hey, this particular choice, once I will reach to the last, I should get the right. And so optimal solution. So you can just hope for the best. All right. So this is about the greedy method. Now, don't worry about that. I will explain you for which problem you need to use the greedy method and how to decide, hey, for this problem, I can use greedy or not. or for this problem, I need to use the dynamic programming or not. I will explain you those in detail. Don't worry about that. So where to use greedy method? This is very, very important question. So always think about a problem. If a problem is following two properties, one is the optimal substructure, second is the greedy property. So optimal substructure is very simple. The optimal solution of the problem contains optimal solution to the subproblem. All right. So what it means? Let's say you want to find the optimal solution out of with the help of n objects. Okay. So if you will remove the one object, let's say, the optimal solution of the subproblem should give you the optimal solution of the main problem. If you feel this kind of problem, it means that problem is following the property of the optimal substructure. Second is greedy property. Well, now what is greedy property? If you make a choice that seems to be best at the moment and solve the remaining subproblem later, you still reach an optimal solution. You will never have to reconsider your earlier choice. What it means is that, let's say I was talking about one example, you want to go from point A to point B, and at point A, you will choose the best possible path based on some criteria. Okay, this way you will keep going, you will reach to the last. So this solution should give you the optimal solution. If that is giving optimal solution, it means this problem is satisfying the greedy property, and we can solve this problem with the help of greedy method. All right, I hope it is clear. So always think about a problem. Whatever problem you got it, just think about these two properties. Is your problem satisfying the optimal substructure property? Second is your problem satisfying the greedy property? It means if I will choose the best choice at the moment and I will keep doing this until I reach the last, will it give me the best solution or not? That is the greedy property. All right. Now I will discuss few famous algorithms, few famous problems which are based on the greedy method in my future videos. So I will be discussing about these problems: fraction knapsack problem, activity selection problem, job scheduling problem, and the minimum number of platforms required for a railway station. And one is the minimum number of coins required to make total using infinite supply of the coins. So these 5 problems I will solve. These are my first target. Okay, in the future I can cover more problems based on the greedy algorithm, but these 5 are the most basic and most important questions which are based on the greedy method. All right. If you feel anything is not clear in the greedy, please comment out. I will create one more videos and I will explain you some of the examples. And in my future videos, I will write down the code for each of these problem and I will explain you how to think about a problem, how to find out I can solve this problem with the help of greedy or not. So stay tuned for the next video, and happy learning everyone. If you like my content, please like, share, subscribe. Thank you everyone.